EMC, ESD, robustness, what's all this about? Well, this is an EMC conference, right? ESD, again, is one of the most extreme forms of EMI. It basically doesn't get any worse than that. You have lightning striking your board and blasting things into oblivion. It will vaporize circuits on the IC. It'll blast wire bonds. It's just bad things. So things we can do to improve the robustness of the circuit board have a lot of good results. One is you always have some type of ESD specification that your product is required to be able to withstand. If you do a good job with this design philosophy, then as I said earlier, you're going to probably have a product that's more robust and will exceed its behaviors in the expected environment, in that it can be able to withstand a more harsh environment, because your customers are going to do everything they can to be mean to your poor little products. And it's all about how do you manage the copper and how do you manage the special components that you may be forced to use in order to allow your product to survive in the environment that it's intended to be used. And now, of course, we're going to talk about electromagnetic fields and how they behave. Because once you understand how they behave, then you can understand what you can do to control them. Electricity is just a bad word for electromagnetic field. Fields are the energy that's used to do all these wonderful things we do. We look at things from a circuit perspective, and that's where we have the idea of volts and amps, where volts are electric pressure and amps are things that flow in wires. And that's kind of the result of a simplistic approach. The math is simple. We can take a very common piece of equipment to measure the voltage. You take your voltmeter and you hook it up to the circuit board and you can read 5 volts. And you can take the leads of your meter and put it in series with one of the conductors and you read amps. And we always thought that was, the electrons flowing through the wires. Neither of those things are true, because the voltage is a measure of the electromagnetic field per cubic volume. It's not pressure, it's a measure of the amount of field that's stored in a space. Amperes are quite simply, it's coulombs per second moving past a space. The current is the energy that's traveling in the space that's defined by 2 conductors. So when you put an amp meter in series with one of the conductors, you're really measuring how much field is going past it by checking to see how much of the field energy is interacting with the structures that you're using in the meter itself. So a certain amount of the electromagnetic field energy is going to be converted into heat or kinetic energy as these fields interact with